Good afternoon. We'll start our first lecture today, and I'd just like to tell you we'll have the first two lectures to review single phase and a three phase. Each will take one lecture, just to make sure that you review the AC circuit, because of course, I mean, you will study the machine, transformer, all needs that you still remember how to analyze and solve AC circuits. So let's start with single phase AC circuit. When you are dealing with AC circuit, then you should use phasor. You should use phasor. Do you understand what does it mean, phasor? Yeah. If you have something like that, the voltage is equal V maximum cosine omega t plus phi. So when you represent it in phasor domain, you will have the value, which is V maximum, and the angle phi shifted from omega t. If you don't have phi, so it means an angle zero. For example, if you say that the voltage, let's say that the voltage is equal 120 cosine 344t plus 30. In the phasor diagram, you have to make it capital and it should be bold, but if you are not typing, you just can make like an arrow like that to say it's phasor, because you have to distinguish between the magnitude and the phasor. That's the phasor. The magnitude will be written like just like that, not bold, nothing in the top of this letter. And the magnitude is 120, and cosine will take it as a reference, so I'll say that the angle is equal 30 degrees. And how you sketch it? You sketch it like that. That's your reference, angle zero. So if the voltage, if this voltage was like 120 cosine 344t, that's it. So to angle zero, you just sketch the phasor diagram of the voltage along this horizontal line. But in this case, it's shifted by 30 degrees and it's positive. When it's positive angle, it means it's going to be above the zero for horizontal line. Well, let's just so we'll just do something like that, and the length should be proportional to the 120, and this is angle zero. So it's not angle zero. It's 30 degrees, so we make a line shifted by 30 degrees ahead of the reference line zero. That should be the phasor diagram. And you can write it as V equal to V, and the length should be proportional to the magnitude. That's the phasor. Okay. Now we have passive elements in AC circuits. We have resistors, inductors, capacitors. And then when we solve AC circuits, we should use impedance concept. What is impedance? What is different between impedance and resistor or resistance? Resistance, it's only scalar value. You can say 20 ohm, 30 ohm, that's something like that. Impedance is more general. It can cover inductors and capacitors too. So if you have a resistance, the impedance is still the same, because originally it just was a scalar value. So if you have R is equal to 20 ohm, it's still the impedance equal to 20 ohm. It doesn't have direction. How can you use the impedance? There is a very simple rule, like Ohm's law. Voltage will be equal, instead of say R, Z times I. And all are phasors. That's phasor, phasor, phasor. What does it mean, phasor? It has a magnitude and angle. So in this case, when you have resistance, no change. You just replace Z by R, and what you get. V equal R times I. No change of the angles. So if you take, let's take one example. If the voltage is equal to 120 on angle zero, and the resistance is equal to 20 ohm, so the M, You divide 120, angle 0, by the resistance, which is equal to 20 ohm, and it will be equal to 6 on angle 0 and they are in phase. So if you have the voltage in this direction, the current will be in the same direction, just different magnitude in phase. No shift, no phase shift. Let's go now to the second one. Here, impedance is very valuable. L, the impedance of L will be J omega L. Let me introduce to another concept called X. X is called reactance. And when you have inductor, it has reactance called inductive reactance, XL. So X is reactance, could be for inductors and capacitors. For inductor, we call it XL, inductive reactance, and the units in ohm. What is Z? What is impedance? Well, impedance will be of the inductor will be equal J omega L, but XL is equal omega L, so it's equal J XL. You can write that. So now the impedance is not scalar. It has a direction here. You can say it's in the direction of the impedance in angle 90 with J. You can write it like that, X. You can write it XL on angle 90. So what do you expect? We expect that when you divide the voltage by the impedance of the inductor, you'll find phase shift between the voltage and the current, between the voltage across the inductor and the current through the inductors. We have admittance. It's the opposite of Z, of the impedance. If you just divide 1 over Z, you get Y, admittance. Let's take an example how we solve this. We have an example. The voltage V is equal to 12 cosine 60t, which means omega is equal to 60, shift is equal to 45. Just to go directly and just say that voltage across the inductor let's say it's equal to 12, and the angle is 45 voltage. And the inductor across is equal to 1 Henry, so it means L is equal to 1 Henry. What you're supposed to do, you have to get the impedance of the inductor. How we get the impedance? First find XL. So let's say XL is equal omega L. I will find omega. That's here. Omega T equals 6T. So omega is equal 60. What is the unit of the angular velocity or omega? It's radian per second. So omega will be equal 60 times L, which is equal 0.1 Henry. It's not 1, it's 0.1 Henry. So it's equal 6 ohm. That's XL. What is Z? What is the impedance? Just add J. So ZL is equal J XL is equal J6, and the unit ohm. Because I mean Z, the difference between Z and XL, it's just J direction, doesn't have unit, so still stay ohms. Now the question is find the steady state current through the inductance. I will just apply Ohm's law in general. Current is equal voltage divided by impedance. So I'll say I through L is equal VL divided by JXL or ZL. Let me just write it XL. So divided by ZL. I just want you to pay attention that not any voltage, not any current. No, the voltage applied to the inductor itself. So that's ZL, which is equal JXL, and that's the voltage applied to the ZL across. Because if you have in series resistor, you got to find out what is the voltage across the inductors to apply this rule. And that's the current through the inductor. So it's very simple using phasor. If you like, I mean, just to make phasor like that, so you know it has magnitude and direction. The voltage across the inductor is the same as the supply, is equal to 12 and angle is equal 45, and the impedance of the inductor is equal to J 6. You can make it 6 angle 90 because J means 90 degrees. And when you divide, you find 2 and 45 degree minus 90, because 90 on the bottom, bring it up as a negative sign. So you have 2, and angle would be minus 45 degree. And that's the current in the phasor form. If you are asked to put your answer in time domain, so you got to change from phasor domain to time domain. You bring it back to cosine. So the answer will be the current. You make a small letter, IL, in time domain is equal the magnitude, which is equal to, and it was cosine, stay cosine. Omega doesn't change, is equal 60, was given here, omega t. And then the angle you added, that's minus 45. So that's minus 45 degree. And that will be the current. And that will be your final answer in time domain. It's just simple to use the phasor. Okay. What about the capacitor? We'll do the same thing. We have reactance, but capacitive reactance equal XC. Capacitive reactance. That will be equal 1 over omega C, different than L. The other one just omega times L. This is 1 over omega times X, omega C. And ZC, it will be minus J. Instead of plus J, minus J. So everything is flipped, you know. That's the difference between inductors and capacitors. Minus JXC. Just I want to tell you about some observation here. When you look for the inductors, what do you observe? The reactance is proportional directly with the angular velocity. If you try to sketch the relationship between omega and XL, it's linearly changing. So if it's 0, XL is equal 0 and just going up. So the reactance of the inductor is increasing with the frequency. What does it mean? Look at the result. What happened when omega is equal 0? If omega is equal 0, XL is equal 0. ZL is equal 0. And if you divide, if you want to find the current, you will say I divided by volt over Z. So V over 0, the answer will be infinity. So at omega equals 0, or when the frequency is equal 0, which means DC, that the current will be infinity. What does it mean? Short circuit. Another thing, you can say voltage is equal Z times I, and D is equal 0 times I, 0. So the voltage is equal 0. It means short circuit. So the inductors behave as a short circuit in DC. And when the frequency gets higher, the impedance gets higher, and the current gets smaller, and can behave like an open circuit in high frequency. Capacitors, they are the opposite. You'll find that the reactance of the capacitor inversely proportional to the frequency. It means if the frequency increase, XC decrease. Let's look at when omega is equal 0, 1 over 0 will be equal infinity. It's coming from infinity. And approach 0 when omega is high. What does it mean? In DC, omega is equal 0, X is equal infinity. When you are working with DC, what does it mean? I equal V over infinity is equal 0. Current is equal 0. So the capacitor behaves as open circuit in DC. That's why. And at high frequency, it behaves as short circuit. Why? Because I mean, in high frequency, omega is equal infinity. So 1 over infinity is equal 0. XC is equal 0. So when you divide, find like short circuit. Okay. So now to find the current, just you use the same rule, Ohm's law. The relationship V is equal Z times I. That's another example. We'll just go ahead and start solving the problem using phasor. The voltage across the capacitor is equal 10. So I'll say the voltage is equal 10. And the angle is equal 30. The unit is voltage. And omega is equal 100. The unit, radian per second. The capacitor is equal to 50 microfarad. So first I find XC. XC is equal 1 over omega C. 1 over omega, which is equal 100, and C is equal to 50, 10 microfarad, 10 minus 6. So you have 10 power 6 in the top and 10 power 3 on the bottom times 5. That cancel will be 1,000 over a 5. It will be equal to 200 ohm. I find the impedance of the capacitor. ZC is equal minus J XC, which is minus J 200 ohm. How can you find the current? The same rule. I is equal voltage over Z. In this case, the voltage is equal 10 on angle 30. Voltage divided by Z, which is equal minus J 200. You can write 200 minus J is equal minus 90 degrees. If you want to make it in milliamps, you just multiply by 1,000 to get it in milliamps. So times 1,000. So 2 zeros, 2 zeros, and you got 100 divided by 2 is equal 50, and the angle is equal minus 60. 30 plus 9, it would be 120. See, I did a mistake, because I mean you have to get this angle in the top will be positive, it would be 30 plus 9. So it's equal 50, and the angle is equal 120 degrees. Milliamp, that's the current. You want to convert it to time domain? Simple thing. You see the current in the capacitor and time domain is equal to the magnitude 50 cosine omega is equal 100 omega t, and the angle is equal plus 120 degree, and the unit milliamp, and that should be your answer. So it's simple using the impedance concept. Yeah.
So capacitors always have phase and take the magnitude degrees. Always.
If you talk about the impedance, yes. The impedance always like minus J means negative 90 minus 90. All right, let's have a quiz now. 6 minutes. Get your paper, write your name, and it's a simple problem. We need to find the voltage across the inductor. Let me give you a hint. You want to find the voltage across the inductor. Use voltage division rule. Okay. One more minute. We got used to solve fast. This question in exam should take only 3 minutes, but because we just were starting, try to. Don't forget your mind. What you need. Okay, let's solve the quiz. If you look at this problem, it's like you have two impedances in series, right? You can call this one Z1 and you can call this one Z2. So actually, you can make it simple like that. Make it like boxes. Z1, Z2, and you have the voltage V, called Vs, for example. And you need to find the voltage across the inductor. Let's call it V2. According to the voltage division rule, V2 will be equal to the total voltage across the two elements connected in series times the impedance, the voltage across, which is equal to Z2, divided by the total impedances in the circuit, which is Z1 plus Z2, will be equal to. Vs is given already in phasor form. It's equal 6 on angle 0 times Z2 is given already ready. So I mean, make it simple and easy. J4 divided by the sum of both resistance, which is equal J4 minus J2. So the answer would be 6 on angle 0 times J4, and J4 minus J2 is equal J2. J cancel J, 4 over 2 is equal 2, 2 times 6 is equal 12 voltage. So the answer will be 12 voltage on angle 0. It shouldn't take more than 1 minute in the exam. I just start by a simple quiz, just because when you start the car, you start, but later, and we're going to have fun, we'll have tricky quiz. But just as a starting, how you think fast to solve the problem. Do you have any question in this one? Okay. All right. By the way, this every lecture will be recorded, and this PDF, I save it as a PDF, and then I upload it to the file system. So you'll find whatever I write is there. Just write the notes that you think it's important, because the old form you'll find it there, everything there. But if something important to you, just write small notes. To calculate the power now, let's move to the power. There are many formulas. I tried my best to write here all formulas used, because you can find power in different forms using different equations. Let me go through it quickly. The most important one, in my opinion, I liked when I was a student, the complex power, S bold. the important thing you got to know, all the formula given here, you use the root mean square value of the voltage and current. So you have to make sure that the voltage and current in the question given in root mean square. If not, transform it to root mean square value. So the S called complex power, and I want you to know there is difference between complex power and apparent power. Both they write like S, both write S, but there is one bold and there is one not bold. What is the difference? The not bold one, apparent power, just you multiply the magnitude of the voltage times the current magnitude. That's it. You don't look for the phase. For the complex power, you multiply the voltage, phasor, magnitude, and angle, times the current, phasor, magnitude, and angle. So it will give you in the end, the complex power, magnitude, and angle. And that's very important. Let me just give you a quick example. If I have, okay, I don't have space here. Let me just open something else. Okay, to do, yeah. All right. Let's say that you have a voltage, phasor, is equal to 120 and an angle 30. And you got a current is equal to 10, angle minus minus 15. And it's given all values are root mean square. We need to find the real power, the reactive power, the apparent power, the complex power, everything from the voltage and the current. If you are just asked about the apparent power, it's very simple. Apparent power, we'll just write like that, S, apparent power. You just multiply the magnitude. So it will be like 120 times 10. And your answer is equal 1200, and the unit, volt amp. If you want to find the complex power, S volt, I just write like that. It will be V, magnitude and angle as a phasor, and I, phasor conjugate. You got to flip the angle of the current. Remember that. So let's see. The voltage 120 and the angle is equal 30. The current is equal 10, angle negative 15. The conjugate will be plus 15. That's the meaning of the conjugate. And then multiply. You get a phasor form. So complex power, and I'll tell you now why they call it complex power. So you got 1200 volt amp, and the angle 30 and 15. Then you add will be 45. And the unit, volt amp. What does it mean in complex power? Observe the magnitude of the complex power, it's equal to the apparent power. The only difference, the angle that you got, 45. What does it mean? I will sketch this one. 1200 and angle 45. So if I make a triangle, that's not a good triangle. If you have, that's 1200 volt amp magnitude, and the angle is 45. If you resolve this parent power 1200 into horizontal and vertical component. So what you'll get here, you get 1200 cosine, let me call this theta in general. Theta, which theta is equal 45 in our case. Cosine theta, and the vertical component will be 1200 sine theta. In our case, theta is equal 45, it means radical 2 over 2, sine and cosine, they are equal. So you have 1200 times, and the same thing in our case. This component is the active power or real power. And what? And this component is the reactive. So actually the complex power can be written as P plus JQ. That's what you got. So if you resolve this into two components, cosine and sine, you get real and real power and reactive power. The unit of the complex power or apparent power, volt amp. This one measured in watt. W. This is reactive volt amp. So how you got the active and reactive power from that's why the complex power I like it, just you can get everything. Okay. Let's go back to our formula and see what to do. That's the triangle I just did, the bar triangle. That's the apparent power S, that's Q, that's P. How can you distinguish between the inductive reactive power and capacitive reactive power? Because the reactive power of inductors and capacitors are different in the direction. Positive Q, if it's positive, if Q is positive, you just draw it upward. This is for the inductors. That's the inductive reactive power. If its capacitor will be negative, it will be in the bottom. You oppose each other. This example you can work it out at home. It's just similar to what I just did, and I give you the answer so you can test if you can understand. Exactly the same, just different one. I want to talk about something else. Power factor correction. How can you calculate the power factor? And what's good power factor? What's bad power factor? And how can you correct the power factor? If you go to this triangle, we sketch the same triangle here to find out. That's S, P, Q, and that's the angle theta. The power factor measures how much power, how much real power, how much active power the consumers consumes with respect to the total power or apparent power provided by the supply. So power factor originally it's equal P over S. How much what? Because the company, utility company produce S and you take the P. If you are taking a small portion, the utility company it takes penalty according to the power factor. Because if you have power factors, low power factor, it means you are taking more power than you consume. So there is a penalty according to the power factor. Power factor is good when it's above 0.94. Bad, it's below that. So it means if I sketch for you two triangles, that's one triangle for the power, and that's one triangle. Which one is better? The top or the bottom? The top one. Why? Because P, the power P and S, they are close in the magnitude. But look at this power here, and that's S, it's less. So power factor is between 0 and 1, and every time getting closer to 1 is better. What happens if you have bad power factor? you got to, the different, let me just check at these two triangles. You said that this is better than this one, and that's right. What do you observe about Q in both? Q here, it is smaller than Q here. Because if you are consuming less power from the apparent power, it means you are consuming a lot as a reactive power. So to do or to correct the power factor, you got to minimize Q. So how you minimize Q? You minimize Q by adding capacitor in parallel to the load. Why? Because we agreed just that the reactive power consumed by the load, usually inductive load, it's upwards, and the capacitive downwards. So if you add capacitor in parallel, the negative will cancel the positive, and then you will have a smaller Q. And that's how you correct the power factor. So if I give you an example here, and that's what you have, and let's say that theta is equal to third degree, and let's say S is equal 5,000 AM. So if we ask what's the power, can you find the power? Yes, you can find the power. See, the power is equal to 5,000 times cosine theta. So we have 5,000 times cosine 30. We get 433 watts. What about Q? Q would be 5,000 times sine 30. 5,000 sine 30. That would be equal to 2500 volt reactive voltage. Let me check if I get the power right. I think I missed 1 0. Sine 30. Yes, I missed 0. Looks small. That's 4330. So that's the power and that. What about the power factor? We said power factor, you can divide it P by S, you have both, or you can find equal cosine theta. Why I'm saying P over S? Because this is general rule. If you are in interview in Georgia Power and ask you what's the power factor, don't say equal cosine theta. I know it's equal cosine theta, but if you say that, so you don't understand the meaning of power factor, and I'll tell you the reason why. You'll say it's equal, it's the ratio between the real power P and the apparent power S. This is the right definition. It's only cosine theta if the current and the voltage are pure sinusoidal, no disturbance, nothing in it. But there is no pure power. We're talking about ideal case would be that's sine and that's sine, that's cosine wave, pure cosine wave. It doesn't happen because I mean we have nonlinear loads on the network in the system, so it causes distortion in the waveform, and once cause distortion in the waveform, so the current and the voltage will not be pure cosine or sine wave. In this case, you cannot say cosine theta. You say cosine theta between cosine and cosine, or between sine and sine. So this is the mean. But in our case, I'll write cosine theta because I'm dealing with ideal case. Everything is pure sinusoid. So I would say cosine 30. So cosine 30 is equal to 0.866. And it's not enough to say that 0.866 lagging. Power factor doesn't have unit, but it's either lagging or leading. You may ask, how do you know it's lagging? So we use positive. I'm done? Yeah, I'm done. Well, just 1 minute to correct this power factor. Let's say ideal case. I want to correct it to unity power factor. I'm very greedy, and I'm going to have it power factor equal to 1. So what you will do, I will add to the load capacitor, and this capacitor should produce Q or take Q equal to 2500 to make it unity. Because if I have 2500 on the negative, it will cancel the Q and the P equal S, and I have unity power factor. So I will say that the Q produced by the C should be 2500 reactive var. This right var. All right. In this case, what is the value of the capacitor? Now you go Q. Q also can be equal V squared over Z or over XC. We know that the rule, I mean, power is equal I squared times R or V squared over R. I give this in the handout, you'll see. Q is equal I squared times X or V squared over X. In this case, I'm dealing with the reactive power, Q. I'll say Q is equal V squared over X and XC. I want to find C. From this equation, you have Q, 2500. You have the voltage given, let's say 120 voltage, you square it. Then you got XC. And that's it. You know XC from frequency, get C. That's it. So thank you. I'm sorry that I make you late.